Hey everyone, again, it's Mr. Nelson here, working on some stoichiometry. This time it's Mass Stoichiometry. We're in practice sheet number 8, problem number 2. So here we go. If a shiny strip of zinc metal is placed in a blue copper 2 sulfate solution, the zinc dissolves slowly while copper metal forms. The blue color of the solution gradually fades, leaving a solution of zinc sulfate. Write the skeleton equation and balance it for the above chemical equation. So let's look at this a little bit more slightly earlier. It says if a shiny strip of zinc metal is placed in blue copper 2 sulfate. So we have zinc and we have copper 2 sulfate. So zinc, Zn. And if we want to double check that, we're going to look at our periodic table. And right here is zinc, and it is Zn. Go back to our problem. Now we're going to have copper 2 sulfate. Now copper 2 sulfate really means that it's a type 2. So we're going to have a plus 2 for the copper. Now the sulfate, what is the charge for sulfate? Well, we need to go to our periodic table, or our classroom packet. And let's just go down to the bottom here and find sulfate. Sulfate is right here, okay? Sulfate is SO4, but it's a -2. So let's go back to our problem. We know that that's going to be a -2. Well, since they cancel each other out, we don't crisscross. We just have one of each one. So we're just going to put in here that we're going to add to that. The zinc is going to be added to that copper, Cu, and then sulfate, if you remember, was SO4. Now let's double check with both of those. Let's go to this sulfate, SO4, that's what that is right there. And we go back to our periodic table, and we find that copper is right there, and it's Cu. So we're good with that. So let's go back to our problem. Okay. To that, we're going to yield, because the zinc's going to dissolve slowly while the copper metal forms. Okay, and the blue color of the solution gradually fades, leaving a solution of zinc sulfate. So the copper metal forms. So we're going to put copper. And then to that, we're going to end up having zinc sulfate. So remember, zinc was Zn, and sulfate, Zn, and sulfate was SO4. Now here's the thing. What's the charge? Zinc is what charge? Well, if we go back to our packet, if we scroll down to page 12, right here, and we look at zinc is a +2. So go back to our problem. We know that zinc is a +2, and sulfate from up here was a -2. So we don't have to worry about it. We have one of each one, so we don't have to crisscross. We just put down one of each one. So let's go ahead and bring those back together. And that's what we have. So there's our solution right there. That's our skeleton equation. So we're going to go ahead and write down right here after what we have. We've got to balance it. So let's go ahead and balance it. We have zinc and, zinc. On this side, we have just one zinc. Oh, we forgot to ask one question. If it's by itself, is it diatomic? Is zinc diatomic? No, it's not one of our 7 diatomic elements. Is copper diatomic? No, it's not. It's not one of our 7. Remember, our 7, if we go into our periodic table, are going to be nitrogen, oxygen, fluorine, chlorine, bromine, iodine, these 6 making a 7, and hydrogen. Okay, so we have hydrogen, and then we have these ones right here. Okay, those 6. So let's go back to the problem. So it's all written good. So we end up having 1 on this side. I come over to the other side, and if I tab over, we have 1. And then we have copper, Cu. And on this side, we have 1. And on the other side, we have 1 copper right there. And we go down and we have SO4. Now, again, if I have SO4 on both sides, I can write it down as SO4. So it's SO4, SO4. And we only have 1 of those. And I go to the other side, right here, there's only 1 also. So there's 1 here and there. So we're going to put a 1 right there. So, hey, we're already balanced. So our molar ratio is going to be 1 to 1 to 1 to 1. So let's put that in there, 1 to 1 to 1 to 1. And then I always like to put these numbers in here, 1 there. There Move that over. 1 and 1. And again, I like to highlight these ones. I don't know what it is about me, making sure it's organized. Everything gets to be organized. We can see what it is. Okay. And we have that. And all these are going to be highlighted in yellow. Again, yes, this takes a long time to do it, but if you're precise on everything you do, you're going to work out. Now let's go ahead and we're going to do the stoichiometry. Now I'm going to say when we do the stoichiometry, we have to do the molar masses. So we're going to do molar masses of what we have and what we're looking for. So what we have always has a number with it. So let's say if 1 gram of zinc metal, so that's our first one, zinc. So we're going to have Zn, okay, and actually, Zn, there's just one. There's no other one after that. So we have 1 times whatever the molar mass of zinc is. We go back to our periodic table. And let's go back up to the top here. And scroll up to our periodic table. Zinc is right here. It looks like it's 65. It's the large number that's in the box. So it's going to be 65. And that's going to equal 65. Okay. So we know that there's going to be 65 grams per mole, and that's going to be per 1 mole. Okay. Now we also have, we're looking for, where is we looking for? Is how many grams of copper metal. So now we're going to do copper. So Cu for copper, and we have up here we have 1 copper. Okay, that's going to be times whatever the molar mass of copper is. There's copper, so copper is 64. Back to our problem, times 64. That's going to equal 64. And that's going to be grams per mole. Okay, and I always like to highlight these right here in green. Now, normally I'd highlight the rest of it in yellow, but because there's only 1, we can just highlight that in green, and that'll be good enough. So let's go down to the stoichiometry. As always with stoichiometry, we're always going to start with what's in the problem. So we have 1 gram of zinc metal. So we're going to come over here. We're going to put 1.00 gram of zinc. We're going to put our times in a line. But again, we can't put the line in until after we get done. And we know that since we have to go to the bottom, we have to get rid of grams of zinc. So we're going to put in our molar mass of zinc, which is 65. So we're going to put 65 grams of zinc. Okay. And on top, that equals how many moles? Well, remember that's 1 mole. Low number means 1 mole, so that's going to equal 1 mole of zinc. Okay. Then what we're going to do is we're going to do our molar ratios. But see, I can put my line in there now. So we're going to put our line in there now. So times in the line. We do another times in the line. And then on bottom, we have to get rid of moles of zinc. So we have to put moles of zinc on bottom. But what moles do we use? We're using our molar ratio up here. And since they're all 1, we can go ahead and put just 1 mole of zinc equals, and now again, we're going from zinc to copper. So that equals 1 mole of copper. Now again, where did I get that? I got that from right here. So 1 mole of zinc equals 1 mole of copper in this reaction, and only in this reaction. As long as that reaction is balanced, we can use these coefficients as moles and say that we have the equal numbers of each one. So we're going to go ahead and underline this one now. Oops, let's go back, put that back, and then put our time sign in. Now we're going to do our molar mass in reverse. So again, I have moles of copper here, so I'm going to go down to the bottom, and we know that we have 1 mole of copper. Okay, that's right here, 1 mole of copper equals 64 grams. So we're going to put that on top. So we're going to put 64 grams of Cu on top. That's going to equal grams of Cu. And we're going to underline this. And now we have everything. All we have to do is cancel everything, then go ahead and do our math. So as long as I have it on top and bottom, we can go ahead and get rid of it. So I have grams of zinc here, so we're going to get rid of that. I have grams of zinc here. And get rid of that. That's on bottom. On top, I have moles of zinc. Notice I'm not really getting rid of the numbers. I have moles of zinc. Now, I could on that one right there because I do have 1 mole. But I like keeping the numbers and just saying ones we don't have to deal with. Okay, so we're going to go ahead and moles of copper on top and moles of copper on bottom. So I'm left with grams of copper, and that's what the answer. And let's look up here. It says how many grams of copper metal. This looks good. One of the next things I like to do is I like to put down how many sig figs. So here's our number right here. And we look at this, and sometimes we say, oh, there's only one significant digit because there's only one number. But there are zeros here, and sometimes those zeros are significant if they're trailing. And that's right, if there's a decimal in the number, and there is a decimal in this number, so that means we're going to have 3 sig figs. Okay, and again, I like to go ahead and change that just up with the color a little bit. So we're going to put our answer in here once we get it, and we're going to do all these ones right here as we go through. So we're going to put those in yellow. And again, be patient because you know what, you got to do it. You got to make sure that you're doing it right. It's so easy to make a mistake. I've made thousands of them, and you've probably seen me make mistakes. So hey, it happens. So if we just don't rush through it, we can get through it. Now we're going to go ahead and do the math. And remember, the math is always going to say that we are going to multiply by the top, divide by the bottom. So we're going to take 1. We're going to multiply by 1, divide by 64. Then we're going to multiply by 1, divide by 1, multiply by 64, divide by 1. But we don't have to do any of the ones. So we're just going to get rid of those. And the way that we're going to do our math is we're just going to do it this way. We're going to come over here to the calculator, and we're going to say we're going to do this one first. So we're going to say 1. So 1 divided by 65. And then we're going to multiply it by 64. So our number actually should be less than 1. So let's see what it is. It works out. It does. It is less than 1. So it's going to be 0.984615. And I can go on and on and on and on with this. Now again, sometimes we say that this is a stoichiometry, but I'm going to say it's the answer. It looks like I might have spelled it right. So that's a theoretical answer, and that's going to be we don't put that right there. I'm going to delete that or copy that. We're going to put that right there. That's where that goes. I'm sorry about that, guys. Put it in the wrong spot. See, always can make mistakes pretty darn easy because we're putting them in the wrong spots. So that's our answer that we have right there. But we have to make sure that we are putting it in the correct number of significant figures. So we need 3 significant figures. Now this 0 right here, is that significant? Well, there's a decimal in the number, but it's preceding. All zeros at the beginning are never significant. So we're going to start right here. We're going to go 1, 2, 3. So we're going to put our line right there. Okay. The 6 says we round up. So again, I like to put in a characteristic. We're going to put a character there. We're going to make the arrow go up because we're going to round up. So this 6 says we're going to go to the 4 and we're going to make it a 5. So we're going to come over here and we're just going to go and change that 4 to a 5. Now we can have grams of copper. And that would be our theoretical answer. Okay. Okay. Now the actual yield was 100. It was only 101. So I got to change that because that can't be higher than our actual yield can't be higher than what our theoretical yield is. So we're going to change this to 0.851. Okay. That makes it a little bit better. So we're going to go 0.851. We'll put that in there. So now what we're going to do is we're going to come over here and excuse me. We're going to put in our percent yield. Our percent yield is equal to our actual yield, and then it's divided by our theoretical yield. Okay. So we're just going to go ahead and underline that, and then what we do is we multiply that by 100%. Okay. So now that we wrote out the formula, and I'm going to say you have to write out the formula to do this. Otherwise, you're going to lose points. You don't write out the formula because now we just plug in where we have the actual yield, the theoretical yield. So that's going to equal our actual yield, which is 0.851 grams. Okay. And then our theoretical yield was 0.985 grams. Okay, and then we're going to multiply that by 100, and that's going to be a percent. And we'll underline this. Okay, and then that's going to equal, and let's see what the calculator says. So we'll go back to our calculator. So we're going to have 0.851 divided by 0.985. That's going to equal this number that we're going to multiply that by 100, and that's going to be 86.3959. So 86.3959, and we can keep going, but the problem is we only need to go to right there, one place after. Remember, around to one place after the decimal. So this says right here that we are going to insert a character, so that is going to be up. Go back, and this one now we're going to round that up. So my 3 becomes a 4. So our final answer is going to be 86.4%. And that's going to be of copper. Okay, and again, I should have a percent here of copper. And we're going to highlight this one in yellow. Because again, it's not all the answers. This one's right here also in yellow because this is something that we did. Okay, and this one's something that we did. And then that's part of the problem right there. And that's our answer. Hey, looks like we got our answer. We go all the way through. And hopefully I didn't make a mistake. Hey, we'll find out, won't we? Hey, as always, our answer down here at the bottom, is 86.4. Percent or percent yield, which is not too bad a percent. Hey, as always, go Mohawks. Hey, Nelson out.